My dear friends, we have talked up to generator protection 7 and we were in abnormalities, abnormal operating conditions. In today's talk on generator protection 8, we will cover 3 or 4 more abnormalities, which are very important and many of them are quite complex too, as we shall see. The first abnormality is, the first abnormality we have seen, that is the unbalanced loads. This is the second abnormality, which is a field failure protection. If the field of the generator that is connected to the infinite bus fails, and we are not talking of isolated generator which is connected to the infinite bus, the field of that generator fails, then it is a very complex phenomenon. Field can fail because of many reasons. DC supply may fail, exciter may fail, field breaker may open out, whatever the cause, but generator rotor is not fed with the DC current. So according to Fleming's first right hand rule, the flux is lost. So generator will not generate power. And therefore it will lose load. And because it loses load, it will speed up. The speed of the generator will increase. Because the machine which loses load, the speed will increase. And the machine, the speed of which is more than synchronous speed, is an induction generator. Therefore, the synchronous generator will start working as an induction generator. And because it is working at a higher speed, it will take more load with reference to other generators. It will feed more load to the bus with reference to other generator. It will feed more active power to the, so active power is generated, but reactive power was available from the field, right? So reactive power is not now available. And because the reactive power is not available, it will take reactive power from the finite bus. Now, if the machine which has lost the field is smaller machine with reference to the remnant system, generating capacity, then there is no danger on the system. But machine is taking higher load. Therefore, its stator will start taking the current ranging from 2 to 4 times depending upon the speed at which it is now finally stably working. Higher speed, but at that higher speed it will be stable because now it is issuing load. Therefore, its speed will be under control, but at higher speed. But it will take more current, so stator insulation can be damaged. But stator insulation will be damaged due to higher current, and it is due to heat generated I square RT. Therefore, it's a function of time. You have not to take actions immediately, right? Secondly, because the machine is speeding up, there will be a sleep generated in the rotor, and sleep frequency current will be generated in the rotor iron, and rotor iron will be overheated. It will endanger the rotor insulation, rotor winding insulation, and finally rotor winding will be damaged. So field failure is a complex phenomenon. Both the reasons, rotor heating and stator heating, are function of time. You have to wait for 4 to 5 seconds. How do we sense this field failure? You see, that is very important. We are sensing field failure by a distance relay, the characteristic of which is an offset Moore relay. Its diameter is XS, that is synchronous reactance of the generator, and it is offsetted by XT dash by 2, that is half the transient direct axis transient reactance. So if the impedance seen by the relay enters this, and you see, we have learnt in B.Tech classes, B classes, that the impedance which was seen in first quadrant when it was working as a synchronous generator will now, when it is working as an induction motor, induction generator, it will be in fourth quadrant. So the impedance seen will enter in fourth quadrant. And when it enters this characteristic, the action starts. And action is time delay because it's a function of time. Overheating is a function of time. And after that time delay, the machine will be operating in class B trip mode. Class B trip mode means we are just closing the turbine and boiler. We are not closing generator. We are not opening generator breaker. Therefore, machine will go on feeding power. We will utilize this kinetic energy of the machine. But then power will slowly come to zero. And before it comes to zero, low forward power relay will sense. And low forward power relay is a class A trip. Therefore, finally class B trip is going to result in class A. So the characteristic is like this. The characteristic is offsetted. The reason is less technical but more historical. And that was told by my great guru, Dr. Date, that once, at that time, the field failure characteristic was passing through origin. But at that time, the false sleeping occurred, that is loss of synchronism occurred, characteristic 3, and it crossed this field failure. Therefore, field failure relay maloperated or operated, whatever you can tell. And therefore, the generator was disconnected from the bus. And finally, because it was a big machine, it led to the complete dark out in whole of the America. 5 companies were feeding America. All generators were disconnected from the bus, and it was a well-known. I do not know the date, but it is a very well-known dark out in America, and its analysis was done. And in the analysis, it was found that a small girl, some 4-5 years old girl, in the multi-story building, she touched with a wooden stick 132 kV line passing by, and she waved it, and therefore there was a flashover between 2 lines, and that flashover led to final dark out. Therefore, people from that date decided that we should offset this so that the field failure is independent of the out of step operation. Out of step is a different phenomenon. We have to act on it, but that is a different phenomenon, right? So we are not talking about that. We are talking about field failure. So now, because this characteristic is not in connection with out of step, it is an independent characteristic. But now this time delayed operation will cease if the machine is big. If the machine is 210 megawatt, or say even if it is bigger, 500 megawatt or 660 megawatt, then its reactive power component was quite high. So it was feeding quite a big reactive power to the bus when it was working as a synchronous generator. Now it will lose that reactive power and will start consuming reactive power from the bus. So infinite bus has to feed double the reactive power that was generated by the machine. And double the reactive power if the total system cannot take, then the system will collapse. The field failure of one machine will lead to total dark out in the state. So it is a very important thing. It's a very important phenomenon that you have to see to it that the machine is rather you will be stopping the machine instantaneously rather time delayed. So how will you sense the instability? Instability is connected with the collapse in voltage. So with the field failure, if collapse in voltage is found, if the voltage at the generator PT secondary is less than 70% of rated voltage, then the instantaneous strip will be issued by fill failure relay, by fill failure mechanism to fill failure protection mechanism to save the total system from going out of step. So this way, field failure is time delayed too. If the total system is not under danger, it is instantaneous if total system is in danger. So little complex, but it is class B protection. So that is field failure protection. Then next is overload protection. Overload protection is not very stringent. It's not very complex. Overload means consumers are taking more load than what is generated. So after all, you will have to do load shedding, but load shedding will be done by uh, the load dispatch center people. So that is not an issue with the generator in charge. So if you are sitting in generator control cabin, then you are concerned with your generator. So if your generator is overloaded, if your machine is 210 megawatt and it takes 220 to 30 to 40 to 50 megawatt, then what all you have to do is, because it is overloaded, it will take more current because voltage is constant. So it will take more current, and more current will endanger the uh, stator insulation. So to save the stator insulation, you have to take step, but it is overheating. So once again, it's a function of time. You see, 1.4 times the current, probably the machine can take up to minutes. So that curve will generator manufacturer will give. And if the generator crosses the load beyond 105 to 110% of the rated current, then you take steps. And taking steps is very easy, just very easy. Just you throttle the steam to the turbine, so that turbine will issue less mechanical power to the generator, and generator will deliver less electrical power to the bus. That means you are controlling your power. Very easy. It's a very easy action. And therefore, overload protection is neither class A or class B. You are just using a definite time overcurrent relay. After some time you take action, it will simply sound an alarm. After a definite time, it will sound an alarm. Generator in charge will take actions. He will throttle the steam to the turbine, and he will. Then overload is there. That has to be taken care of by the system people. That is different. We are talking about the generator right now. So that is the overload protection. Then there is over voltage protection. We are not talking about over higher frequency. High frequency transient over voltages like lightning and switching over voltages. Those are taken care of by the uh, the lightning arrestor, which is connected at the generator terminal. That is a different thing. We are talking about power frequency over voltages, and power frequency over voltages are either caused by overheat, over speeding of the machine, or by loss of load, big load from generator, abrupt loss of load. So then usually in modern steam driven generators, there are turbine governors which will immediately act. It will issue a command to the automatic voltage regulators, and modern static AVRs, automatic voltage regulators, are sufficiently fast to prevent the serious over voltages from occurring. And it is an auto loop. Usually you have not to take action. But if AVR is also under danger, AVR is also damaged, then you have to take from auto to manual, and you have to reduce the voltage by controlling the field. But if you cannot do so, then over voltage is damaging the stator insulation. And therefore, you see, it is class A protection. Over voltage protection is a class A protection. So that one has to remember. Throttling steam is easier, but in hydro turbine, throttling water is little quite more difficult, because the fluid is more viscous, and therefore uh, it will it can uh, endanger the turbine valve, right? Therefore, you cannot immediately throttle the water as immediately you can throttle the steam. So the usual practice is to give instantaneous steam at 25% over voltage, and in hydro 40% over voltage, and To initiate inverse time unit, if the overvoltage crosses 10%, that means it will be voltage time characteristic is inverse. Higher the overvoltage, less is the time, lower the overvoltage, more is the time. Such relays are available in numerical world also, and you do get this, right? So this you have to take action, and as I told, it is a class A protection. So that is the overvoltage protection. Now, very important protection is reverse power protection. And usually we do not use reverse power protection, we use low forward power relays. That means when the power fed from machine to the bus is less than certain value, usually 0.5% to 3% of rated power, then the protective system will act. And because it is endangering turbine, it is heating the turbine, you can wait for some time. Because you see, internal fault within the generator is also power is reversing. So at that time, the differential protection is going to act instantaneously. So to discriminate that, reverse power protection is time delayed because heat is involved. And very important, it is not endangering the machine. That is very important because when reverse power will occur, reverse power will occur when turbine fails. Turbine fails means turbine is not getting steam from boiler. That means the steam valve in between is chopped somewhere. Either steam control valve or steam stop valve or any other valve from boiler to turbine. There are many valves in the root, and if any valve is chocked, then steam will not be fed to the turbine. Now, therefore, turbine will not generate mechanical power. So, the machine, synchronous generator will not feed power to the bus. Therefore, it will act as a motor and it will run the turbine as a pump. But to run the turbine is very easy. The current would be hardly 10 to 20% of rated current. So electrical machine is not at all under danger. But turbine is under danger because turbine is not getting new steam. But whatever the steam which was entrapped, it will be turbulated inside the turbine. And it is very hot steam. You see 540 degrees centigrade. Heavy pressure. So that hot steam turbulating will be damaging the turbine blades, and therefore reverse power protection is not for the electrical machine, it is for the turbine. In hydro machines also, new water is not coming, but old water is going out. Therefore, there will be cavitation, and cavitation will generate a force, and that will endanger the turbine blades. So, in any machine, basically, reverse power protection. In diesel generators, diesel generator will misfire. So, in any machine, it is basically reverse power protection is for protecting a turbine, and it is time delayed. But then it is class A protection. And as we discussed, all class B protections are routed through low forward power relay. So low power forward power protection is very important. Therefore, people are using two low forward power relays, that is duplication, and one reverse power relay. So triplication, so to say, very costly, but very important. Therefore, the cost is involved. One more important thing with this one has to remember is we are talking about 0.5% of the rated power. So the rated current is 9050 amperes, right? So 9050 amperes, 1% is 90 ampere, right? And half percent is 45 ampere. And that 45 ampere is going to secondary side 2000 times less. 45 divided by 2000. That is 22.5 divided by 1000. Right. So 22.5 divided by 1000 is some 22 milliamperes, or maybe some 50 milliamperes at the most. So if I consider 10,000 ampere also, right? So because 10,000 by 5, then it will be 100. 1% will be 100 and 0.5% will be 50. 50 divided by 2000. And 50 divided by 2000 is 45 divided by 1000. So some 45 milliampere of current is involved. So 45 milliampere, you see 30 milliampere is consumed by the magnetizing path. Protective CT consumes 30 milliampere as magnetizing current. Now this is 45 milliampere. We are left with only 15 milliampere to sense the protection. Therefore, very specially manufactured CTs are required, which can transmit, which can transform this very low current, because current will reduce. You see, when power is reduced, voltage is constant. Root 3 VI cos phi. Root 3 is constant. Cos phi is constant. V is constant. So only I has to reduce. So to sense such a small current, very specially constructed CTs are required. This we have never learnt in our during our studies. This I could learn from one of my students who is working in Siemens and is involved with commissioning of generators. So he talked about this. So I'm getting very good feedbacks from my students who are working in field. So I get to know that so important is, I mean, CT is very costly. Therefore, reverse power protection is very costly and it is triplicated, right? And as we discussed, all class B protections are routed through reverse power protection. So this is very important protection. One should not forget that it is very important. The circuitry is very simple. 32 GR, GY, GB fed to CTs by CTs. 32G fed by PTs also. 32 is a number for low forward power relays. And then the DC circuitry is this, that the 32GR, GY and GB are normally operated. Therefore, 32GX is operated. Therefore, 32GX1 is open. So the protection does not operate if the machine is normally working. But if the power is less than 0.5 or 3%, whatever is said, then 32GR1, GY1, GB1 will open out. 32GX will de-energize. 32GX1 will close. 2 by 32G will be energized timer, because it is a time delayed. We will wait for 3 to 4 seconds. And then 2 by 32G will initiate class A trip command, because this reverse power protection is class A trip. In between, there is steam wall interlock circuitry. It is in the scope of boiler manufacturer. It is very important because you see, when you start the generator, when you are starting, it is not connected to bus. So it is not generating any power now. So 32 GR, GY, GB are already open. So trip command is already sitting and generator will trip when you start. This is not required. Similarly, when you are stopping, what you do? You see, when you want to stop the machine for maintenance, you will not stop immediately. You will not open the breaker immediately. You will reduce the power by throttling the steam from 200 megawatt to 150, 20, 15 to 1, 0. So at 0, the machine is floating. Then you open the generator breaker. Then you open the field breaker. Then you open the, then you stop the steam stop valve. Then you will stop boiler. There is a sequence. There is a regular sequence. Otherwise, there will be many damages to boiler, turbine, etc. Therefore, while you are stopping at that time also, zero power means 32 GR, GY, GB will open and trip command will be issued. Instantaneous trip will occur. That is wrong, because you want to intentionally trip the, open the generator. You want to do the maintenance. So while starting and stopping, the reverse power protection should not operate. Steam wall interlock circuitry takes care of this. It allows the operation only when genuine turbine failure is there. So that is very important to note. So having told so much, I end today's talk. Little short, little long also, because the protections are very complex, very important. Yet we have to discuss few more abnormalities, and that we will discuss in generator protection 9, and then in generator protection 10 we will conclude. So till then, my friends, please stay tuned with Adapt.me. As I told, we do not have any marketing network. My viewers are my marketing engineers, my YouTube viewers, and I'm very happy that in LinkedIn, you see, from Indians and from my students, I will get like. because my students have studied under me, so they will like me. That I can very easily understand. But I am getting likes from probably China, Korea, Malaysia, Oman, uh, Middle East countries, UK, from different countries. Because I'm reading the name, I'm being able to know that I'm getting likes from different countries. So adapt me is spreading, but it has to spread to billions of engineers. So that is the business and function of my viewers. My viewers are my ambassadors. So please share to as many engineers as you can. Till then, my dear friends, thank you. And for India, it is good night because it is quite late. It is about 11 o'clock. So for India, good night. But for other countries, uh, I wish a very nice day for you. And thank you for patiently hearing me. Thank you all. Attention.